and I will share my screen. Okay, can someone confirm me that you can hear me and you can see the slides?
Yep, looks good. I can see it.
Okay, good. Thanks. Okay, so hey, thanks for taking your time and joining the Blue Jeans today. Um, so today the TripleO deep dive is about Puppet things. So well, we started the TripleO deep dive so people can understand how TripleO works under the hood, and I thought that it would be useful uh, uh, to explain a little bit how TripleO is using the Puppet modules and why we are using that, how it works under the hood. So today this is about explaining the Puppet things in TripleO. If you have any question, just enable your mic and go ahead. So just to make sure anyone knows me, my name is Emilien. I work in the engineering team for Red Hat. I've been working on deployments for a while now, and I'm currently leading the Puppet OpenStack modules. I'm the PTL, and yeah, I'm working on Puppet things for quite a while now. So if you have any question about Puppet in the future, you can ping me on IRC, and I will help you. I'm also working on TripleO and trying to make the TripleO deployments faster with Puppet modules, and that's it. Okay, so let's start by the agenda. So yeah, I will start by an introduction just to make sure that everyone uh, is on the same page about the Puppet OpenStack modules, what we are doing here, and what is the uh, how do we work, etc. Because I guess in the future, or if not already, you will contribute to the Puppet modules, maybe. Maybe because you want to fix a bug or you want to add a new service or something. The second thing we will see together how the services are running. Sorry, I forgot to change the slide. We will see together how the services are deployed with Puppet TripleO. So we are using Puppet profiles. I will go into details about this. The third topic will be about how do we use the Puppet profiles in the hit templates. So you will understand how TripleO is going to be composable, and you will be able to choose what services you want to run on which container or which node, depending of your architecture. And we will have a short conclusion about how you can bring your own service in TripleO. So let's say you want to bring a new Neutron service. How can you do it? So I will try to explain you how to make it. And we have some time for questions at the end if you have. But if you have any question during the presentation, please just go ahead and shoot. Okay, so let's make an introduction about the Puppet modules. So the mission statement is actually very straightforward. We try to bring scalable and reliable IT automation to OpenStack cloud deployments. So what it means is that we have a lot of Puppet modules, actually 36 Puppet modules to deploy almost all the OpenStack projects. So we have modules for Nova, Keystone, but we have also modules for some project like Watcher or Octavia or some project that maybe you don't know. So this is a Big Ten project, which is supported by the OpenStack community. We are following the same cycle release model as TripleO, which is also the same as the other projects in OpenStack. We make a release every 6 months for the new OpenStack release. We have we have a huge continuous integration testing. We are testing a lot of things, and the exciting things that we are testing are the actual TripleO jobs. So we are running multi-node testing on top of the Puppet modules. So if you're submitting a patch in Puppet Nova, we will actually deploy some nodes and test that you can deploy Nova and configure it, and Nova is actually working. The the thing is that we are using the RDO trunk on master. So every day we are testing Puppet modules against OpenStack master. We are working very closely with the Puppet community, and the modules are working with the official Puppet Labs module. So for example, in TripleO, you will see that we are deploying Apache. So the Puppet OpenStack modules actually work with these modules supported by Puppet Labs. We did not fork our own modules, and we did not create everything. We just use what the Puppet community is using and what Puppet Labs is actually supporting. If you want to know more about Puppet OpenStack module, there is a link. Of course, you can see the slide after this presentation. I put the link on the Etherpad, so if you want to just click on the link later, you can find the official documentation about all of this. So who are using the modules? A lot of people actually are using the Puppet modules. Of course, TripleO, but also some people deploying OpenStack in production for public clouds, for private clouds, and some installers like TripleO and Fuel from Mirantis. So this is a lot of use cases and quite a diverse community based on operators' feedback. So we are building the Puppet modules from operators' feedback, which is good for us. We are actually working closely with the operator community. So if you look at the composition of a Puppet module, what does it look like? If you take, for example, Puppet Nova, and you list the directories and the files, you are wondering what are the lib directories. So the lib is containing the resource types. For example, the Puppet modules have some providers to create some resources. It can be a glance image, or it can be a keystone user or keystone endpoint. So we have a bunch of resources that we are managing with Puppet, and they are living in the lib directory. But the most important thing are the actual manifests, which are doing all the configuration and orchestration for us. If you look at the manifest, you will most of the case find the same structure every time. You have a init.pp file, which is the standard class for the command bits. If the service has an API like Nova, for example, you will find all the bits to deploy the Nova API in this class, and so on. So yeah, you have basically all the bits that you can use to configure your service, and you will see that everything is split across different sections, which are actual class in Puppet. So if you want to configure Keystone, I think you will find a class for Keystone in the module that will configure all the bits that you need for running the service. You have a file which calls params.pp. It contains all the packages name and service names because they are different on specific distros like Ubuntu and Red Hat. So it depends on which distro you're running, and yeah, you can find it here. So if you want to add like a new service, you have to make sure that this service is you can deploy it on Red Hat, but also on Ubuntu, and that's something you can see in this file. And yeah, like I said, use to discover other classes because each module has specificities like Nova and like Neutron and so on. And finally, there is a spec directory. It contains the unit and functional tests. And yeah, that's it. Most of the case when you have to patch Puppet modules, you have to update the test. It's very straightforward, but it's happening in this directory. If you look at the link I put before, you have everything you need about the test if you want to learn about how to write tests, but we are not going to cover it in this presentation. Okay, so like I said before, maybe you already did, or maybe you are going to, but it's probably you are going to do your first contribution in Puppet OpenStack. This slide is just to make sure that you understand how we like to write the Puppet module. So obviously, you have to document all the new parameters. If you want, for example, to create a new parameters for Nova, because something has been implemented in the last cycle, you want to add it in the Puppet Nova module, you need to add some documentation. If you are dropping a parameter, you need to deprecate it correctly with a Puppet warning, and you have to support the parameter at least one cycle. I won't go in details for this because if you look at the code in all the Puppet modules, you can already look the deprecations. They are very, very easy to read, and it's just very important to take care of it when you write your patch. If you're creating a new parameter, you have to set the value to OS service default because that's a Puppet thing that we created. So we just don't configure it by default and we rely on the OpenStack defaults. That's something we introduced in the Mitaka cycle and you can now use it. Of course, if you create a new parameter or a new class or even a new module, you need to obviously create the unit test and the functional test. Because like I said before, we are investing a lot in the CI and we want a good coverage of testing. So yeah. We have some coding style, which is documented in the website I gave you before. Not everything is documented, but most of the bits, and it's good to follow them. And of course, your patch has to pass the CI jobs, because if it works for TripleO, if it works for Fuel, if it works for the integration jobs that we have, there is a good chance that your patch will be good to go. Okay, what is a bad contribution now? Obviously, no documentation, no tests. Something I can see most of the time is that people try to set a default value to an opinionated value. Like, for example, if you create a parameter in Nova and you set the default value to, I don't know, false, but the default in Nova is true, that's something we just don't want, because it means that you have an opinion of the value which is different from upstream, and we just won't do it. So you have to use the service default at least. That's something that we just mentioned before. Obviously, don't break backward compatibility. Like I said, we have some operators running the modules in production, and yeah, we try to not break them at every release. If you're not following the Puppet standards, if you're trying to do some crazy things with Puppets, Puppet is not a bash script. You have to respect some code syntax. If you want to learn about Puppet itself, you can go ahead with the official documentation. I'm not going to cover it here, but we still have some conventions like you have in Python and other projects. So yeah, sometimes if you get -1 because someone tell you, hey, no, this is not how we can do in Puppet. So yeah, you can understand it because Puppet have some standards too. And obviously, yeah, don't break CI. Just don't do that. Okay, do you have any questions so far? I think we are good in the timing. Okay, let's go to the next chapter. So, how do we do Puppet profile? What are Puppet profiles in TripleO? So the user story in the that we had in the past before implementing the profile, we were getting the feedback from the field, and as a deployer, I would like each service containerized and or isolated from other services, which means that I want some tooling which enable me to deploy Nova API separated from Nova Conductor, for example. So before that, before this work that we did in this cycle in TripleO, we could not do it because everything was all the services were composed together on a controller role, and same for compute and storage. So we had this monolithic manifest in TripleO that we stopped to maintain in the Newton cycle. I will give some details after. So the idea was to be able to isolate the services each others. So yeah, like I said, we had this monolithic manifest that you can find in in Mitaka and before in Liberty and so on. So you have this controller manifest that contains all the bits for deploying a controller, but it was too opinionated for people on the field. They wanted to choose and select what they want to deploy on which node. And also the controller became a bottleneck because yeah, we had too many services on the controller and some performance issues and so on. And yeah, basically we had a huge technical debt in the manifest because we were wrongly using Puppet modules. We were hard coding the classes definitions into this manifest, and it was just not good for us, not flexible, and so on. So we created the TripleO Puppet profiles. So what are the profiles? You have to think about think containers where you want one service per container. In the TripleO profiles, it's mostly the same. You want one service is one profile. So for example, you would have uh, a profile for Nova API, one profile for Apache, one profile for NTP, and so on. The service logic goes in the Puppet OpenStack modules. That means that if you want to deploy Nova API, all the configuration bits goes in the Puppet Nova module, but the TripleO specific logic goes in Puppet TripleO. So for example, we will just look at the code after this slide. For example, we have some profiles in TripleO, which call TripleO profile base Git API or pacemaker Apache. We will see afterwards how it works. And we have some roles that will include later the Puppet classes needed to deploy a specific service. So we will see afterwards what are the roles and how does it work. There is one thing which is very important to understand here is that we are using Puppet to do the configuration and the orchestration, and we are using a stepwise deployment. So we did that before already, and we will continue to do it during the next release. So what is a stepwise deployment? Um, it's actually a step-by-step deployment where we build our TripleO cloud step by step. So for example, at step one, we are bootstrapping the cluster with pacemaker, HA proxy, TripleIFD. We are building the database with MySQL Galera, and we are building RabbitMQ cluster. At step two, we are validating the cluster. We start to create the safe cluster. we create the Swift ring, and at step 3, we know that the cluster is ready, the database are ready, so we create the OpenStack database and we run the dbsync. At step 4, we configure the OpenStack services, we configure Apache, and we start the services that are not managed by Pacemaker. And at step 5, the last step, we start all the services managed by Pacemaker. So this is like an iterative deployment, so we can fail fast if something's wrong during a step. I'm not going to give much details in there, but that's something we would like to continue doing in the future. We are currently investigating how to do a step validation, so you can actually understand why your step is failing. For example, if at the step number 3, the OpenStack database creation is not working, it's not created, you want to fail immediately and you want to know why. So we are working on this. There is a public discussion on the mailing list. But yeah, that's something you needed to know about Puppet deployments. We are doing stepwise deployments. So I'm going to show you an example of a Puppet profile. So let's take the example with Nova API. So this is an example of code which is in a Puppet TripleO module. You can find it. So if you look from the top, we have some parameters. They are given with Hira, and also they are given when you call the profile directly from another class. So that's something that people who know Puppet, they know how the parameters work. There is some logic in this manifest because Nova API was running with Pacemaker, so we wanted to run the dbsync only on the Pacemaker master. So if you look at the second thing, we have some logic to run the dbsync only on the master node. Most of the services have a common class for the common bits shared across multiple services in the same project. For example, Nova API and Nova Conductor, they share a common class in Puppet module, which is the Nova class. So basically, you need this class in all the profiles. So we are doing basic Puppet profiles here, and we are trying to include the class as we can, and try to define the parameters with Hira. You can see in the manifest the stepwise deployment, which is driven by heat. So you can see the steps. If step 4 or step 3 end dbsync, okay, let's create the database and so on. And yeah, you can see the pure Puppet OpenStack classes. If you look at the include, you can notice that we are calling the pure Puppet Nova. We are not calling another class to configure Nova, the cron tab or the Nova API service and so on. Okay, do you have any questions so far about the profiles? Okay, let's go ahead with how do we write the composability with hits? So as a deployer, I would like to choose what services to deploy on which physical or virtual server or container. So like I said before, a big limitation of TripleO in the past was you could not choose exactly what service you want to run on your controller, on your compute node. You had to use the manifest that are in the current TripleO hit templates. And basically, everybody was struggling about this because they wanted to add some services, and we could not add more services on the controller. So also, we have some specific architecture, for example, NAV or some architecture with some specific services like the hyper-converged Ceph when you want Ceph running on the compute node, etc. So everybody had a different use case, and we wanted to cover it. So this section is about to explain how it works. So how does it work? The composability. Basically, you want to create a service. So that's what we did just before with the Puppet TripleO profile. So we already covered it, but we are going to explain how it works on the hit side. You also want to register the service and all the services that you will have in your deployment. And at the end, you want to create the custom roles before running the deployments. Okay, so let's see how it works piece by piece. Okay, here's an example again with Nova API. So this is a TripleO service that you can find in the TripleO hit templates repository. If you are not familiar with it, that's one of the biggest repositories that we are doing in TripleO. You can find all the templates where we create the different services that we want to deploy. So this one is about Nova API. You can look. We have a hit template header. So this is a regular hit template. Of course, we have the description mentioning that that's an OpenStack Nova API service. We have some parameters, like we have the Nova workers parameters, for example. We will see later that how that it's used to configure Nova API. We have also the Nova base profile resource, which is included in Nova API. Like I said before, the Nova services share some common bits sometimes. Well, not sometimes, but in Nova it's the case. And for most of the services, it's also the case. They have a base profile for the common things. And this resource is about it. And at the end, we have the mapping between HIRA parameters to configure the service. So HIRA parameters, it's a key value thing where you can configure the parameters in the Puppet modules. For example, if you go in the Puppet Nova module, if you look at the API class, you will see a parameter which is called metadata workers. And we are configuring these parameters here in the service, in the hit template. And we are using the standard HIRA. So if you want to override the Nova workers, you will have to, in your deployment, you will have to change the value of Nova workers parameter. And at the end, you can see the step config, which is including the Puppet profile. Here we are including the TripleO profile based Nova API. So we are just calling what we did before, the TripleO profile in Puppet TripleO. We are including it here to deploy Nova API. And this hit template is about the composition between the Puppet profile, the HIRA data, including the resources that we have in common with the other services, and the parameters. So that's about it. Okay, once you did the service, you need to register the service. So for all the services that you created, you need to register them in the resource registry in this YAML file. So right now it's in this file. If you want to look at the current state of the file, you can open it, and you will see that there is a Nova API service. And at the end, you want to create some roles. Before we had the controller, we had compute roles. And if you want to create your own controller, you will have to register the service to the role. So that's something that we are still developing. Stephen Hardy is actually developing it. I'm not sure he's here in this call, but basically this is still under development. I gave a quick overview in this slide. So if you want to, well, to look how it's going to looks like, that's a quick overview. This is not definitive right now because, like I said, it's still work in progress. But it will basically allow you to compose yourself your different roles. So like we had before, controller, compute, and you can call it how you want. And we will have a dynamic template by using Jinja, and we will just iterate over all the roles, and we will include the services that you want for each role. It's just about composability here, and that's it. So how can you? Then I forgot to change the slide. I'm sorry. Okay. So do you have any questions so far about the composability here? If you have any, if you want me to go in details on something specific, please ask me now. There is one thing to understand about that. It's that the last piece, which is the current slide, the custom roles, is still under development, and I hope we can finish it by the end of Newton. Steve and the group is we are working on it, but basically it will just it will looks like how is it in the slide. So okay, if you don't have questions now, I will go ahead. So the next slide, it's a bit a conclusion about how you can bring your own service in TripleO. So the first step is to make sure. So it's an example with Barbican. Let's say you want to add a Barbican in TripleO, which is the case. Some people want it, but it's not yet integrated. So you need to make sure that you prepare the OpenStack Puppet module for Puppet Barbican. You need to make sure that all the configuration that you need is in the Puppet Barbican, because the configuration won't be done in the Puppet profile in TripleO. Like I said before, the configuration and the orchestration is done in the Puppet Barbican module. So you have to make sure that it does everything you need. And then when you're done with the module, you can go ahead in Puppet TripleO and create the profile. So in the case of Barbican, there is one service, so you need one profile to run the API service, and basically just include the Barbican classes that you need at the step of the deployments. And then when you're done with the profile, you can go ahead with the composable service in TripleO hit templates. So like I showed with the example in Nova API, you can create a new service for Barbican that will set all the HIRA data that you want to configure the service, and to include also the Puppet profile for Barbican and all the parameters that you want, like the workers or the database or keystone credentials and etc. And when you're done, you can register the service by adding the new service to the registry. And then at the end, you can assign the service to one or multiple roles. So that's the last piece is still something that we are doing right now. And we will create some like a dynamic iteration for creating the customized roles. And at the end, you can keep calm and deploy TripleO at wish. Okay, 35 minutes. We have 10 minutes for questions. Please go ahead if you want me to go in details on something specific. And if I was not clear on something, just enable your mic and raise your questions. I don't see the Blue Jeans questions. I can't read it at this time. So if someone wants to ask me, go ahead, please.
Emilio and Michela here. I have a question.
Yeah.
Is there a way to specify kind of constraints between the composable services? Like these two services must be together, these two must not, that kind of stuff?
Right. That's a very good question, and I think we are going to address this thing in this cycle. Right now, Steven is working on the Jinja thing to iterate over the code. Oh yeah, it's here. It's here. You have
Is that a
better
realistic problem? Is there ever a case where we want to force two services to be together?
Well, right now, how we do is that we include the services. Like I said, for example, Nova API is requiring the Nova base. So we are just including the service in the service itself. So we are doing this constraint right now because you have to. But in the case of, let's say, you want Keystone.
But even that should not be a requirement. That's an optimization, right? Keystone should not. Actually, I was going to ask about that. Keystone should be on its own node and not coupled with anything else in HTTPD like this. But it looks like the direction that you're going is that we want to be able to put everything in its own container, and I could see that including all the internal pieces of Nova. So I can't see where we'd ever want to force them together.
Right now, there is no restriction.
It was more a way to describe constraints. I think at the moment we're not likely to do anything of this nature for Newton, but I raised a heat spec a while ago which was about template capabilities, and it's more about saying, hey, if you want to enable Nova API, then you need to include all of your other Nova services, and then they depend on the database, and et cetera, et cetera. And by the way, it depends on Rabbit. At the moment, the operator has to know about all of those dependencies and explicitly specify the list. In future, it might be nice if you could have that relationship defined in the templates, but that capability doesn't exist in our model at the moment.
There are some cases in Neutron where that kind of thing is useful, because OVS is like an L2 agent is required pretty much anywhere that you're actually going to do anything with Neutron.
Makes sense.
That would be one of those situations where it'd be cool to have that. Just say, need an L3 agent and everything comes with it, and so on. So.
Thanks, Amelia. Thanks, Steve.
Okay. If you have more questions, or if you want me to go in details for something I was maybe too short or too quick for you, please go ahead.
Amelia, one thing which I would find helpful, if you could maybe share a terminal and talk through the test tools that are used to test the Puppet modules, because when I first started hacking on them, I wasn't familiar with the way the unit tests were wired in. I don't know if that would be something other people would find useful just to spend a couple of minutes on.
That'd be awesome,
right.
At least for me as well.
Okay, so yeah, the test. So we have two. We have basically two kind of tests. We have the unit test and the functional test. The unit test, they are done with the AirSpec framework. So there is a bunch of documentation online about this. It's basically testing that it's basically testing what you expect the Puppet manifest to do. Like if you expect to configure this resource with this parameter, the AirSpec test will just test that your expectation is good and it's actually working. This is more about this thing, and you have also unit tests for the providers, which is a bit more complex because it's more in Ruby, and it's basically a unit test in Ruby. It just instantiate the resource and so on. So that's a bit more complex. I'm not sure we'll have to do it one day. But the thing is that about functional testing, we are using the standard Puppet Beaker, which is another framework for functional testing in Puppet. Basically, there is nothing much to know about this because the framework is just about you declare the new class in the test, and Puppet Beaker will just instantiate the class and see if the catalog is not failing. It's using the server spec framework to do the actual validation. Like if you want to test if the service is running or if the service is listening on a specific port, we can check that in Beaker. What you need to know is actually the Puppet OpenStack integration thing that we have. Everything is documented on GitHub, and I can put you the link on the slide later. It's basically a set of 4 scenarios that we use to deploy OpenStack. For example, we have the first scenario that deploys Ceph and telemetry, and we will test if what happens if Gnocchi and Nova, Cinder, Glance are configured to use the RBD backend. And so this is a bunch of integration things. We have 4 scenarios to cover a maximum of services because, like I said, we have 36 modules. It's very hard to test everything in one CI job. So we had to split in 4 jobs. You don't have to know anything about new framework. It's just a repository to use. Like if you're creating, for example, a new service in, for example, Brent is working on Octavia today, and if tomorrow the module is supposed to work, Brent can go ahead and in Puppet OpenStack integration create the Octavia manifest to deploy Octavia, and it will run Tempest, and that will be part of the integration testing. We can have integrations with these projects, and yeah. So if you go back in the slides about the Puppet OpenStack, there is a link at the end, only one link actually. If you click on this, this is the official Puppet OpenStack web page, and there is a section about CI. And if you go here, you can go and learn how the CI is working, how you can learn to write testing and so on. But basically, yeah, if you want me to cover AirSpec, we can spend all the day on this one if you want. Okay, there is
thanks,
a
Emilian.
question.
That was a useful overview.
Okay.
Yeah, I have one
Yes, Sanjay.
question. So,
Yeah.
first point was that the slide, the images are not loading. So that's a small thing, but I think there's a permission issue. The other question is that let's say if we have this requirement that we need to have the database on a Ceph volume, is that possible? And if it is possible, how does a operator make sure that's implemented? Let's say, because what I'm trying to say is there some kind of dependency criteria which we can build into the TripleO with the Puppet modules by the operator himself?
So the question is, if I understand correctly, is there some mechanism to validate that the parameters are set if you are deploying Cinder with Ceph?
Yeah.
Basically, if you don't, the deployment will just fail because I guess we are providing some default values for some parameters, but if we don't, the deployment will just fail because the Puppet Cinder actually requires the parameters. So if you don't provide, for example, the RBD, if you don't provide it, which is a required parameter, the deployment will just fail already because it will say, hey.
I think I should rephrase it. So basically, when you're saying the step 1, step 2, step 3, step 1 is where you are installing the database, and step somewhere in the step 2, I think, or in the step 1 later, you're installing the Ceph. Let's say I want to have the database itself reside in the Ceph volume. Can I make that call as an operator? or try to do that?
I'm not sure I get it. If someone can help me.
What
Yeah.
I'm saying is the Ceph volume is created later to database, but when I'm creating the database itself, it should write to a Ceph
Okay.
volume. That's what I'm saying.
Yeah. So the table I gave in the slide about the stepwise deployment was an example. It's not something that is fixed right now. Maybe tomorrow some services will change, which it was just an overview of why we are doing stepwise deployments. It was not like it was not like a documentation of how it works like right now. It's just an overview of why we are doing stepwise deployments. And maybe Ceph will be at step 1 tomorrow. I don't know. That will change. But that's something we did in the past, and we are still using this model right now. So right now the steps are not flexible. If you want to change the step of Ceph deployment, you can't do it right now. But that's something also we can investigate later if there is a need of changing the step number. Okay, there are some questions. Adam, does the L2 agent need to be on the same node as a particular part of the one, just on the nodes? So right now,
That's for Brent. We can have that as an aside. We don't have to have that now.
yeah, but right now, if you deploy Nova Compute if you deploy the Nova Compute service, it will not include Neutron for you. You have to do it. We don't have the constraint in place. Okay.
So it's building the controller. I'm building the compute node is the most thing that you need to specify explicitly.
It's the same. Yeah, you need to specify for any role. Yeah.
So basically, there's just a list per role. So a role is like compute or controller or Ceph storage or Swift storage. And you have a list of services. So each of those service templates that Emilian described, which maps through to a Puppet profile, that's basically you have one item in a list, which is like enable Nova API, and another one, which is enable Nova Compute. And you have a controller services list and a compute services list. So, as an operator, you need knowledge of which services should go on which roles and what the dependencies between them are. So if you need a Neutron agent to run on compute nodes, you would need knowledge of that and add it to the list.
Right. The distinction is between the monolithic controller and where we want to go. I'm not as concerned with the compute node, because compute node I don't think can be broken up any more than it is now. Whereas the controller, the thing that I really want is to be able to have Keystone vary independently of the other services, so that I can upgrade Keystone prior to everything else for upgrades.
Yeah, so until we have containers, if you're running Keystone on a controller node, then that's going to be still quite difficult. If you wanted to dedicate one node just for Keystone, you could do that. Once you've got custom roles and the composable services stuff that's already landed, that will be possible. You would basically define a Keystone controller role and then just deploy the services you need to run Keystone on it.
Right, but I see that we have an Apache role. I'm assuming that's because both Horizon and Keystone run in Apache, and it's easier to keep them together. Can we not do that?
Yeah, so we don't have we have a Keystone profile, and so that maps through to a Keystone service template. All you would do is basically add OS TripleO services Keystone to the list, plus the other services that it needs. I don't think that you would need to specify Apache explicitly. That will automatically get pulled in via Puppet.
I suggest we have a in heat side, I guess.
Yeah, probably, Adam, it might be handy to sort of follow up with like an Etherpad or a mailing list thread where you describe the use case in a bit more detail. Okay. Sure. I know the other day I sent you an email showing you how to run just Keystone on a controller all in one. This is kind of going the other direction where you want just Keystone on a single role and then everything else separated. We're pretty close to making that possible. We need custom roles to land before it's going to be easily doable.
I was assuming with the custom roles.
Yeah, after that lands, it should be possible.
Cool.
Okay, we are reaching the deadline, the time. I would like to thank you for your time and for your questions. I hope you learned something today. And feel free to join me by email or IRC if you have more questions. The slides are public. I see a lot of people connecting on the slides, so I'm sure it works. Go ahead and share it, and if you want the source, let me know. And yeah, thank you.
Thanks a lot, Emilian.
Thanks, man. That was great.
Thanks, Emilio.